Good morning. Today we will continue with abnormal behavior of water. In last class we had seen electric and magnetic effect of current and water, abnormal behavior of water, like we had seen the concept of latent heat. Today we will proceed with 4 degrees Celsius concept. What is it? Suppose this is a glass, right? And anyhow, if you pressurize something, for example, if you will pressurize gas, gas will turn itself into liquid, right? And further pressurizing the same will turn itself into solid. So suppose there is liquid argon. Argon is a gas, but we have pressurized it, so it has turned into liquid. And we have a solid cube of argon also, solid argon. So after some time, what will happen? This solid argon, okay, this is argon, solid argon will settle under liquid argon at the bottom of the glass. You can clearly say this. Okay, any other example if I take, suppose instead increasing the temperature, iron will turn into liquid. So suppose this is liquid iron and here we have solid iron. So you can clearly say that this solid iron will settle. Okay, this solid iron will settle under liquid iron. So this is very clear. Why? Because we know that density of solid is more than that of liquid and more than that of gas, right? So since the density of solid is more, so solid is bound to go at the bottom. You remember like continental crust and oceanic crust. Oceanic crust is having more density, so it settles under continental crust. I hope this has been taught to you. So solid is having more density and liquid is having lesser, so solid is going to settle. This is what is the general phenomenon. Now if you see, if there is water, okay, if there is water over here, so water is liquid, and suppose there is ice cube. After some time, what will happen? Ice cube will settle down? No, it won't settle down. It will float here, right? Ice is not going to settle down. Ice will float. It will melt, but it will remain at the top of that, right? Why is it so? Because density of ice is less than density of water. So this is the abnormal behavior, means density of ice. Ice is solid phase and water is liquid phase. Here ice means solid water should have more density, but it is having lesser density, right? So I can say that density of water at 0 is lesser than density of water at any temperature. Yes. So when density of water is maximum, it is not at 0. This is for sure. What can we say from here? Because ice is solid lesser than 0 or about 0, right? Water is solid at that temperature. So we can clearly say that water does not have maximum density at 0 degrees Celsius or less than 0, sub-zero, that we were expecting, because ice should have shown that in solid state. Instead, water has maximum density at 4 degrees Celsius. This is the punchline of the entire discussion. Okay, this is, you need to remember that water is having maximum density at 4 degrees Celsius. Now see the PPT. Here just see. I'm going to just give you some concept over here. Now this is cold water and this is slightly warm water. Okay? Is it so? No, this is not the case. Now see, if suppose this is the season of winter at higher latitudes or altitudes. So what happened there? The lakes or the water bodies, they freeze, right? So lakes and water bodies freeze. But still we find that the living creatures, okay, the living creatures like fishes, etc., they are able to survive even in those frozen lakes. Have you seen this? Yes. So what is this? That I told you that water is having maximum density at 4. So which is having maximum density is going to settle down or not? Maximum density will settle down. So don't you think the temperature of water here will be 4 degrees Celsius? And this 4 degrees Celsius is way above 0 degrees Celsius. Okay? This layer, the last layer, will have maximum density. So maximum density of water is observed at 4 degrees Celsius. So we can clearly say that the bottom part of the lake or the water body is cool, right? So definitely you can say that this region will have slightly more temperature. So this region will have slightly more temperature because lesser density, so that will observe more temperature. So here up to 4 degrees Celsius, here slightly more, and above there will be 0 degrees Celsius. So there is a contrasting pattern observed in lake. You will find the bottommost at 4, then there will be some more temperature, then everything will settle down. Okay. So this is the property of ice, that because of its abnormal behavior, okay, living creatures are able to survive. Okay. Though the uppermost layer of the water body is frozen, but upper body is frozen, but we are able to, okay, able to find the living creatures to be surviving. This is because of the abnormal property of water, that the bottommost part has cold water like 4 degrees Celsius or 1 degree, 2 degree, but above that the temperature is slightly more, that allows the living creatures to survive. Okay. So this is what is the concept. So with this I request you to solve this question. Okay. Then I will have the discussion. You have 1 to 2 minutes. Okay, Manisha has given her response. I guess option C. Okay, Dhananjay is going for option A. Vikram is going for option C. Okay, I will wait for one or two more response. Okay, let me answer then. See, wherever Dhananjay, your answer is wrong for sure. Okay, I don't know about Vikram and Manisha. We will check. Why your answer is wrong? Whenever there is a junk point or a flip point or a critical point, Anand, Chhawa and Vivek has given option D. Okay, so option C and option D can be the probable answers, but option A and B cannot be the answer because you have a flip point. So you need to be very alert at that point. For example, if you are going towards your house and there is a drain, okay, big drainage system, so you will be highly alert around that, right? Else you can fall in that drain, yes or no, or in that gutter, whatever you say. So you need to be very observant or alert at those flip points. So here water is heated from 0 to 10. So you should be thinking that we should answer either at 0 and at 10, right? Okay. We should also see 4. We should also think about 4. Why? Because 4 is showing different behavior. It is having maximum density at 4. So we will have to see 3 points, not only 0 and 10, but also 4. Okay. So we have a formula, density is equal to mass per unit volume. And you are asked to find the volume. When water is heated from 0 to 10, what will be the effect on volume? So volume will be mass divided by density. So this is the formula you are going to use. I would suggest that these questions have been asked by UPSC time and again, maybe 2 times. Okay, this question has been repeated in different form. So whenever you get such question, please try to use your pen, because suppose C and D can be the probable answers, and if you have got it wrong, definitely it is going to cost you 2 marks and minus negative, okay, 2 by 3. So that is not required. You have plenty of time, so please go by this. So let's assume there should be some assumption. An assumption you need to be very, let's assume mass of water we are boiling is suppose 200, okay, any unit, gram, kg, whatever you want to take. I am just taking without unit because everywhere I have to find the volume. So I am considering mass to be 200, I can, right? Density, now density I have to assume, density at 0, density at 4 and density at 10. These 3 again I have to assume. I can assume anything, okay, I can assume anything. I am going to assume it 10, this to be 20 and this to be 10. This is fine. Why? Because I have kept 20, means 4 degrees Celsius at maximum. You have to just keep this in mind, that whatever the value you are taking, density at 4 should be maximum. So this equation is also right. This equation 10, 20, 5, this will also do the purpose. This will also do the purpose because 20 is maximum. If I take it 5, this 20, this suppose 10, this will also work because this is 20 maximum. But anyhow, if you make it 20, this as 10 and this as 10, this is not going to work because density at 4 is not maximum. Whatever the value you are taking, ensure that density at 4 is maximum. So I hope that you are able to find the set, that which set you can use. Okay, I am going to use any one of the sets. So for my I am going for set C. Any value you can take, you will get the same result. Okay, just keep in mind that density at 4 should be maximum. So this set cannot work. So now just find volume at 0 degree Celsius. So mass is your 200, density is your 5. So 200 by 5 is 40. Volume at 4 degree Celsius, 200 upon 20. The value you will get 10. Volume at 10 degree Celsius, 200 upon 10, that is 20. So what is happening? First it is decreasing from 40 to 10, and from here it increases. So the last set of people like Shava etc. has given the right response. Option D is the right answer. I hope you are understanding this. Okay. There is one question, Anand. Why does water show maximum density at 4 degrees Celsius? Please explain briefly. Okay, that is not much important, but I will tell you if you have asked. See, density is mass per unit volume. So if density has to be maximum, this constraint volume should be minimum, right? So when suppose temperature starts declining, we observe that volume should also be declining, because with decline in temperature, energy of the molecules decline. Because of that they come closer. Okay, so molecules come closer. So if molecules are coming closer, volume is bound to be declining, right? So volume declines. But in case of water, okay, in case of water at 4 degrees Celsius, we find the formation of cluster among the molecules, formation of cluster among water molecules. Because of that, this happens only at 4 degrees Celsius. Because of that, volume becomes very less, and hence density is maximum. पीपीटी पे नहीं किया क्या उतनी देर से? पीपीटी पे है ना? ओके, आई वॉज एक्सपेक्टिंग द आंसर. Okay, if you are not willing to give, or maybe there is some technical glitch, let me answer this. The surface of a lake is frozen in severe winter, but the water at the bottom is still liquid. What is the reason? Ice is bad conductor of heat. I have not told you. Since the surface of the lake is same temperature as the air, so no heat is lost. This is absurd statement. The density of water is maximum at 4. Yes, this should be the this should be the answer. Though the bottommost layer, okay, it is cooler, but it is at 4 degrees Celsius. So 4 degrees Celsius water will be in liquid state. Maximum density will settle at bottom. So C is the right answer. Now let's enter into the domain of surface chemistry. Now what is cohesive and what is adhesive force? This is the crux we want to know. So first you take it in your mind that cohesive force, okay, there is a kind of force, cohesive force, which acts between two similar kind of molecules. Okay, it is intermolecular force of attraction between similar set of molecules. For example, there is a water molecule and there is another water molecule. They come together and say, let's drink. Okay, this is cohesive force. Means the force of attraction between two similar set of molecule will be considered to be cohesive force. Understood? Okay. And there is another concept known as adhesive force. This acts between two dissimilar kind of molecules. Okay. Just say this. Let's suppose this is a water molecule and there is egg. So if water is able to sit on the surface of egg, this is only because of adhesive force. Because the surface of egg shell will have different molecular properties and water is different molecule. So if both are able to interact, that is called adhesive force. Okay. For example, my skin is made up of different molecule and this sweatshirt is made up of different molecule. If both are able to interact, that is adhesive force. This marker, I am able to write on board with the help of marker. So the nib of the marker is made up of different, a different molecule, and this whiteboard is made up of different molecule. But if both are interacting, this is only because of adhesive force. Understanding this? So adhesive force acts between two different set of molecules. Right? So you are expected to write this. First you write, then we will go further. Right? Cohesive force. Cohesive force. Please write. And it is an intermolecular attractive force. It is an intermolecular attractive force between two adjacent portions or two similar set of molecules or two similar set of molecules of a substance. Next you write adhesive force. If you want to write example between water molecules, cohesive forces among water molecules. Okay, next point you write adhesive force. It is an attractive force between two dissimilar set of molecules. Okay, like I am writing on board, etc. Everything you understood. Even the makeup, okay, the makeup is able to sit on your face. Why? Because of adhesive force. The skin and the makeup, whatever you put, has affinity. There is adhesive force, that is why it is able to sit on your face. If you put sand on your face, sand is going to fall down because the adhesive bond between the sand and your face is not that much that it can hold the sand. But between makeup and your face, the adhesive bond is stronger, that is why it is able to sit there. Is it fine? So adhesive force is acting between two dissimilar set of molecule and cohesive among two similar set of molecules, as simple as this. Now this gives us the concept of surface tension. Okay, just see the PPT. Suppose we have three molecules over here. Okay, three molecules. The first molecule is, I am considering 3 water molecules. The first water molecule is surrounded everywhere by water. This one, everywhere by water. So everywhere it will experience cohesive force. Water molecules will be around that particular molecule, so it will feel only cohesive force. The second molecule is slightly in air and mostly submerged in water. So there will be adhesive force between air and water, and there will be cohesive force among the water molecules downward. The third molecule is equally at the interface of water and air. Because of that, it will experience adhesive force of air and cohesive force of water, but this force will be slightly more. I hope the entire discussion was not very easy for few of you. So let's break it. Okay. Let's break the concept. Now just see this. This is a water molecule. This is again. You can clearly see this is completely submerged in water. So here there will be water molecule. Okay, everywhere there will be water molecule. So what is the definition of cohesive force? Definition of cohesive force says it is the force of attraction between two similar set of molecule. So it is surrounded by similar set of molecule. So do you believe that there will be only cohesive force or not? Yes, there will be only cohesive force, right? Here you see this is slightly at air and mostly here. So here air molecules will be there. Okay, air molecules I am just making like this square, and here there will be water molecules. Okay, so this is circular water molecule. So water molecules will share same attraction, cohesive force. So E cohesive force, and here adhesive force. Yes or no? Similarly for here adhesive force and here cohesive force. Okay, wherever the molecule will change, definitely the character will change. So you can consider this molecule. You understood this? Okay, I will just give you another example, okay, so that you can understand. Consider this to be unmarried person. I am a male, so I will give you example of male, okay, though I am not experiencing at present, but maybe in future. And this is engaged person, okay, engagement has happened, and this is a married person, right? Now suppose there is unmarried one, right? So he has only one woman or one woman in his life, his mother, okay? So there is nothing, so only love, cohesive force between mother and son, okay? There is no question of proving your love to your mother. Everything is fine. You got engaged, okay? So you got engaged. So mother is again dominant person in your life than your fiancé, because she had just entered. So, but yes, there are two poles now. Now your mother or your fiancé may think, okay, that in whose side you will be there. May think, I am not saying that they will think, may think. So this can slightly create a trouble in your life. But this trouble will be not that much because you are engaged. But once you get married, okay, your wife and your mother, if they are at two different fronts or two different poles, I am telling you there is going to be Mahabharata in your life. Okay, adhesive force will be stronger and cohesive force will be equally stronger, and you will be there who will face the problem. So to face the tension of marriage, you should either be engaged or married. This unmarried person is not going to face any tension of marriage because there is no other woman. So that is why here surface tension is 0, right? And engaged or married person will always have to prove his love, his loyalty to either of the women. So there will be again question of what? Question of tension. So marriage tension will be observed by these two people. So here there will be some surface tension and here there will be surface tension. So for water molecules, to observe surface tension, water molecules must be at the surface. So surface tension is observed by the water molecules of the surface, not under water molecules. Okay, under water molecules do not face the problem of surface tension. It is only observed by the top layer. I hope you are understanding this. Okay, so please write surface tension, then we will discuss some of the applications. Right, surface tension is the property of surface of a liquid to resist an external force caused due to cohesive force. In other words, surface tension is the tendency of a liquid to shrink into minimum surface area, So whatever I have made you written, try to understand what I am trying to say. So I will just discuss few of the applications of surface tension. If you write it parallelly, this will be better. Give heading applications and write it parallelly. Okay. The first application is this, that water strider is able to walk on the surface of water. Have you seen that if there is there is water logged, okay, near any road or anywhere else, you find that there are small insects which walk on water. So you can see that the limbs of these small insects are putting pressure on the surface of water, and water is behaving like elastic, that it is offering that film so that it can walk. Okay, so the first application is water strider, which is an insect, is able to walk on surface of water. There are many applications, we will discuss one by one. Okay. Second application is suppose this is water, surface film of water, and suppose they are mosquito. So mosquito eggs, they also float on water. Why? Because of surface tension. So water has surface tension, because of that water has high surface tension rather. So because of that those mosquito eggs float on water. Then you are asked to put some kerosene oil or any other oil. So kerosene oil is put. Because of that mosquito eggs sink. Here they float. Why it happened? When kerosene oil is, so kerosene oil has relatively lower surface tension. So lower surface tension and higher surface tension make surface tension to be low. So overall surface tension declines. Because of that these eggs do not get much elastic help from water and they shrink or they sink. Is it fine? So mosquito eggs, they also float because of this. Next is, suppose, do you know about jaundice? Jaundice means what? Your bile comes out of urine. okay, comes out of urine. So if you see how jaundice test is done, so jaundice test. So first suppose there is normal urine. So sulfur is put in that normal urine, sulfur. So what happens? Normal urine has some surface tension, because of that sulfur floats. Okay. Now here, second case, when your urine is having bile in it, for example, if you are suffering from jaundice, so it will have bile in it. So when you put sulfur in it, what happens? Sulfur sinks, because surface tension of urine declines, because bile has relatively lower surface tension. Bile has relatively lower surface tension. So because of this, in this case, person is having jaundice. So he is considered to be jaundice positive in this case. Water molecules try to gain spherical shape. Okay, this is also because of surface tension, because more will be the area. Okay, more will be the area. More will be the tension. So that is why it minimizes its surface area. So this is done to minimize surface area, and hence to reduce surface tension. For example, some people give you tension in your life, so you want to keep yourself away from those people or those events, right? So the same happens with water molecule. Being spherical, it has lesser surface area where the tension can work. So that is why it minimizes surface area to reduce surface tension. Apart from that, capillarity. Capillarity is also one of the manifestations of surface tension. Capillarity is also one of the manifestations of surface tension. So what is meant by capillarity? Okay, have you seen that if there is a towel and a part of towel gets itself inserted into a water bucket or a bucket filled with water. So what happens after some time, half of the towel becomes wet because water moves upward. Have you seen this? Suppose this is water, okay, and only a part of towel is. So after some time you will observe this part of towel is wet. If you will give more time, okay, you will find this much towel is wet. So water starts moving upward. So this phenomenon is called capillarity. This is capillarity. So what happens here? If you see here, water molecules, they have cohesive force among them. right? Water molecules have cohesive force among them, and water and towel, they have adhesive force. So water and towel both have adhesive force. Because of that, water rise because of the working of these cohesive and adhesive force. Is it fine? Because these cohesive force, so this cohesive force does what? Binds water molecules together. And this adhesive force does what? Helps water molecules to rise. The same phenomenon you can observe, the capillarity phenomenon you can observe in xylem and phloem. So suppose I am talking about xylem, okay? So xylem intakes water and minerals to the upper part of the plant. So this is suppose xylem. So again here, water molecules will have cohesive force that binds it together. So this is cohesive force acting between water molecules. And xylem and this have good adhesive force, because of that water rises. So this is the working of cohesive and adhesive force together, which leads to the action of capillarity. Okay. And other example you can also take kerosene lamp. Suppose this is kerosene lamp. So there is wick of kerosene lamp, right? This is wick of kerosene lamp. So kerosene molecules will be together or seen as together as cohesive force, and kerosene and wick will share adhesive force. Because of that it rises. Okay, so please copy these things. There are some questions. Vikram, so sir, in case of water strider, cohesive force is greater than adhesive force. Yes, cohesive force is more there than adhesive force experienced by air. If that will not be more, water will not behave as elastic. Like in case of test tube. In case of test tube, cohesive force and adhesive force are not that much. Their cohesive force is weaker than the adhesive force. That is why we see the meniscus. Okay, Vikram, I hope you understood. Rohit, can we say in surface tension which helps liquid to maintain their spherical structure? Yes, Rohit, I discussed this. Copy this and try this question. Today there is no prompter, so it is getting delayed. Prompter नहीं लगाया आज? नहीं एक होता है ना रिस्पॉन्स वाला जो, अरे लगा दिया करो उसमें, बोलने की क्या जरूरत? हाँ कोई नहीं, अगली क्लास से लगा दो, ठीक है. Okay, let me do. I think there is some problem. So if capillarity is not there, it would be difficult to use a kerosene lamp. Yes, this is right. It would be difficult to use a kerosene lamp. Next, one would not be able to use a straw to consume a soft drink. Right? This statement is wrong. One would not be able to use a straw to consume soft drink. No, this is wrong. Because it will be difficult to consume soft drink. Why it will be difficult to consume soft drink? Because capillarity makes it easier. Okay, because of capillarity, the soft drink molecules will rise easily. Okay, so that is why it will be difficult, but you will be able to use because you are a living creature. You will just suck it. Okay. Next, the blotting paper would fail to function. Blotting paper like your stripes you use to clean your face, so that kind of blotting paper, napkin etc. or tissue paper you can understand. So yes, they will, because they also suck water or the extra moisture. So big trees that we see around would not have grown on earth. Yes, this is right, because if you are thinking about 10-meter tree, it is okay, but if you are thinking about 100-meter tree, okay, then 50-meter tree, then what will happen? This statement has a lot of importance, right? Because at that height, carrying water against gravity is really something challenging, and that can only happen if the cohesive force and adhesive force are in action. So this statement is right. So option 2 is wrong only because not able. If instead it was written difficult, it was right statement. So 1, 2, 1, 3 and 4. Option B is the right answer. Monica has given option D. Option B. Just you have got confused by the language. Okay. Last topic of physics, Archimedes principle. So let's understand with some example. Now just see this. Suppose your height is 5 feet 5 inch. Suppose your height is this, and not you. Suppose there is a person whose height is 5 feet 5 inch, a person, and the person died. Okay, this was unfortunate incident, he died. So he was a Christian by faith, and there were coffins of different size. This coffin was 6 feet, this coffin was 5 feet 5 inch, and this coffin was 5 feet. So you can buy any of the coffin for the same. But let me tell you, this coffin will be a troublesome buy, because the body will not be able to fit in ease or with ease. But this will be okay. Here anyhow you will be able to do the purpose, and this will be very easy. So if you want to fit that person, definitely you will need that much space, okay, at least around that height. Is it fine? So just think, if there is a 1 kg stone, okay, and you are putting this in water, so what happens? Water is removed by this. Water is removed by this 1 kg stone. That is why you find splash in water, that water is moving here and there. So what it is trying to do? It is trying to replace water. It is trying to replace water. So if 1 kg stone is there, okay, weight, and here if I write water replaced, how much water it replaces. So if it is replacing water less than 1 kg, so it means it is unable to fit. So this thing will sink. And if it is a 1 kg stone and it is able to remove water more than or equal to, it is going to swim or float. Are you getting this? For example, 5 feet 5 inch person getting only 5 feet coffin will unable to fit, but equal to or more than he will be able to fit. In the same fashion, if it is a 1 kg stone and it is removing only 800 grams of water, definitely it is not giving that much importance to that water body, so it is going to sink. And if it is doing it equal to or more, it is going to swim or float. So this is your Archimedes principle, that if any water body, if any object is removing water more than its weight, okay, it is converted into volume also, then it floats. So first write Archimedes principle, then we will discuss bit more. Right. Any object completely or partially immersed by देखने में दिक्कत हो रही है. Any object completely or partially immersed in a fluid fluid means liquid or gas, okay, fluid means liquid or gas. So any object completely or partially immersed in a fluid is acted upon by an upward or buoyant force. By an upward or buoyant force whose magnitude is equal to the amount of water displaced by the object, whose magnitude is equal to amount of water displaced by the object. Now just see this. Are you able to see this? Suppose there is a 10 kg block, okay, and you are putting it in water. Suppose this block is removing only 4 kg of water, okay, this is replacing only 4 kg of water. So definitely it is going to sink, because if it had to swim or float, it needed to replace more than or equal to 10 kg of water. So it replaced only 4 kg of water, so it is bound to sink. But if it is sinking, then that 4 kg which it replaced, okay, acts in upward direction. Because of that, the weight of this block is compromised. So this block will weigh you around 6 kg if it is underwater, because it has replaced 4 kg of water. So the amount of work it has done, that is compensated. For example, your syllabus is 100% and you have completed only 40% of the syllabus. So next time when you start your study, you need to just observe 60% of the syllabus. Yes, that is what is the case. If 10 kg is there, it is removing 4 kg of water. 4 kg will be compensated in the weight because of the Archimedes principle, the upward or buoyant force. Okay, I will give you daily life example. Have you ever pulled out water from a well? Okay, you must have. Few of you may not have. So if you put water in a well, so while pulling the string or pulling the rope, you find that the bucket is very, light when it is underwater. Why? because when bucket is thrown into the well, it replaces some water, which is compensated in the weight of the bucket. Because of that, you feel like a superhuman when the bucket is inside water. But when the bucket surface, it comes on the surface, what happens? You start feeling like an ordinary human, because the amount of energy is more, because the bucket is not that light as it was underwater, because underwater a buoyant force was acting, but here this is not the case. So you need to call some of your brother or sister, please help, else you will get into the well, if not that strong provided. Second example, if you have ever gone for fishing also, so when the fish is there, if it is a heavy fish also, 10 kg fish, so when fish is underwater, so when you are pulling out the pulling out that string or anything, so it is very light, but when the fish comes on the surface, okay, you feel difficult to handle the fish. Think about the fishermen who use a huge net and they also pull out fish out of water. So when the net comes on the surface, they call other fishermen to help, because now the Archimedes principle or the buoyant force is not working. Else next day's newspaper will give you result, what? That मछलियों ने मछुआरे का शिकार किया. Though this sort of news can be there. So Archimedes principle is very much important. So now I am going to deconstruct Archimedes principle once again, so that there is no confusion in this for those who have not yet understood. Now just see, if there is iron nail, if it is put into water, what will happen? This iron nail will sink. This is going to sink. Understanding this? Why it is going to sink? Because iron nail replaces less water than its weight. Okay, so I can say that density of iron nail is greater than density of water. So this is also deduction of the same. Okay, so this principle was harnessed to get you a ship. So suppose this is a ship. Ship is also made up of iron, but this ship floats. So iron ship floats, but a small iron nail, it sinks. Why is it so? Because when ship is built, the compartments are hollow. Ship is made hollow, and if compartments are made hollow, volume increases. Because of that, density of ship decreases. And if density of ship decreases, so density of ship is less than density of water. So if density of ship is less than density of water, it means ship replaces more water than its weight. So do you find a very beautiful relationship between density Now this is submarine. This also works on the same principle. Okay, so this is a side view of submarine. Okay, so there is a ballast tank here. So when the captain thinks that we need to come on the surface. So what happens? This ballast tank is made empty. So what is done? This ballast tank is made empty. So it becomes empty. It means density of the submarine declines and it surfaces, it moves up. When the captain decides that we need to disappear, so what happens? Ballast tank is filled with water. So because of that, density increases and it sinks. So this is how submarine acts. Okay. So this finishes our physics, not cosmic physics. Cosmic physics will be the last portion. So physics is in daily life. We finished here. Now we are going to start chemistry that we will cover today and a class to follow. And the last two classes will be for cosmic physics. So let's start with chemistry and presenting you the agenda. So these are some of the concepts that we are going to see. Okay. So broad concepts are written over here. We'll try to finish it. Okay, shall we move? What is matter? The first question is, what is matter? So matter is anything which has mass and it can occupy some space. So matter is anything which has mass and it can occupy some space. For example, this glass. This glass is matter. I am matter because I have some mass and I can occupy some space. Okay, your pen, your laptop, your mobile, your headphone, anything, everything is matter which is occupying some space and has some mass. So with this we will discuss states of matter. How many states of matter we are having? So you are expected to copy everything from board. In chemistry very less dictation will be there. So you must be knowing we are having three states of matter: solid, liquid and gas. So three states of matter we are knowing. So if I say, if I move from solid to liquid to gas, energy increases. There is a question, how does center of gravity work in moving objects? Please explain. Dear Vikram, I have told you from the first class that this is general physics and general chemistry. Okay, so we will be doing only those concepts which are important. Center of gravity, first I need to tell the whole class that what is center of gravity. Okay, then we need to go in the law of mechanics. Have I taught you mechanics? No. Does UPSC ask questions from mechanics? No. So we should not bother. Solid, liquid, gas, right? And after this there is one more state which is called plasma. So plasma is considered as fourth state of matter. This is your fourth state of matter. Solid, liquid, gas and plasma. So I can say that from solid, liquid is having more energy, gas is having some more energy and plasma will also have more energy. Now do one thing, that gas, how can we provide energy? Either we heat gas. So if you will heat gas means provide, if I write triangle it means heating, or you put gas under electromagnetic radiations. So these are the ways of giving energy to gas, and if you will do so, your gas will be charged. So charged or ionized gas is nothing but your plasma. Okay. So if you will heat solid, for example ice is there, so heating ice will give you water, and water after heated will become vapor, and vapor if provided further energy will turn into plasma. Okay, this is what I am trying to say. So either you put it under electromagnetic radiations or give it heating effect. So that will be charged or ionized, and this charged gas is known as plasma. Plasma is your fourth state of matter, which constitutes almost 99% of state. Means whatever the things you are observing, 99% of the things happen to be in plasma state. And till today you were not knowing about plasma, few of you, okay, because it is not taught till class 10th. Okay, so plasma is fourth state of matter. So where plasma is found? Where plasma is found? Plasma is found in ionosphere. You must be taught in geography about ionosphere. Why it is called ionosphere? Because the oxygen and nitrogen over there are charged, or the some gases which are found are in charged state. So that is why ion means charge, ionosphere. Second is fluorescent lamps. What are fluorescent lamps? We will see in next class. I have to deal with the concepts of fluorescence, etc. So fluorescent lamps. Apart from that, in stars you will find, because in stars temperature is too high, and star is nothing but lump of gas, right? So in star you will find gas and the temperature will be too high. That is why you will find it in plasma state. Okay. So ionosphere, fluorescent lamp, stars, and interstellar medium. Interstellar medium we will also see in 5th class. I will tell you about interstellar medium. As for today, just know that interstellar medium is space in space. Okay, it is the vicinity of space we are talking about. So it is mostly found in higher space. That is why you are not observing plasma on Earth. On plasma on Earth can be found in the form of fluorescent lamp, etc. So this is all about plasma. 1 or 2 line we will write about this, but that will not be based upon this. So have you copied this? Please write in line. Like gas, plasma does not have, like gas, plasma does not have definite shape or volume, unless enclosed in a container. Shape or volume unless enclosed in a container. Enclosed in a container. Write further. Unlike gas, plasma can make structures like beams and filaments. You can see the filaments, etc. in the PPT. Beams and filaments under strong magnetic field. under strong magnetic field. Okay, so this is like gas only. Okay, it will not show you any different characteristics, but if strong magnetic field is present, it can form such structures. So that is why if you ever see any Hollywood movie based upon space, you will find this sort of electric structures, okay, the filament structures in the cosmic world. So they are trying to just manipulate this concept. Okay. Now atom. Atom is nothing but fundamental unit. Okay. Okay. Anurag is asking about Bose-Einstein condensate. Today, Anurag, I have taught you only 4 states of matter. This is because I am talking about visible world today. Okay. Bose-Einstein condensate I will teach you in the last class or second last class, I can't say probably, when I will be talking about dark matter. So Bose-Einstein condensate has a direct relation with dark matter. So that day I will talk about Bose-Einstein condensate. As of now, just know that this is the 5th state of matter, which is in super cool state having zero energy. So atom, right, and matter. Matter I have taught you, anything is matter. So matter is made up of atom. So atom is fundamental unit of matter. You, I, everything is made up of atom. So atom is nothing but fundamental unit of matter. So how atom looks like? So atom looks like this. So there is a nucleus, and nucleus is surrounded by various orbits. This is orbit 1, orbit 2, orbit 3. Okay, it is surrounded by various orbits. Nucleus have 2 residents, neutrons as well as protons. Neutrons have 0 charge, that is they are neutral, that is why they are known as neutrons. And protons are having +1 charge. Okay. And orbits, in orbits you will find electrons who revolve around nucleus. Electrons have -1 charge. And the property of electron I had told you when I was talking about Raman effect, that electrons have great affinity towards light, so I am not going to repeat. Okay. So as of now, just know that these orbits are there and it is having -1 charge and they have having +1 charge. So if I break it further, atom is made up of 2 things. First is your nucleons. Nucleons means what? Neutron plus proton, and electron. Right? So matter is made up of atom, and atom is made up of this thing, nucleons, that is neutron or proton, and electron. Do we have more fundamental things than these things? Any more prion, etc.? Yes, we do have. For example, nucleons are made up of quarks. We need to learn about quarks. And electrons are made up of leptons. So we'll do it. Means quarks have made your protons and neutrons, and leptons have made electrons. Now if you see, any atom or element is represented like this. Suppose it is represented like this, X, here there is Z and there it is A. What is this? I will tell you. Have you seen, teachers used to write about C612, H11, right, He24. So what is this? What is this? What are these numbers? Okay, these numbers are important because we need to observe those numbers if we want to understand nuclear physics or chemistry that will be taught in technology. So till then they will be writing about uranium 235, uranium 238, okay, everything will be there. So what is this? So the representation is done like this of any element or atom. So here there is Z. Z represents atomic number. Atomic number is equals to number of protons. Okay, number of protons. In general, number of protons and neutrons are equal in general, but not always. So that is why I am writing this only, number of protons, and it should be equal to number of electrons if it is uncharged, but we should not enter there, keep it here, equal to number of protons. This is the basic definition. And this A is known as atomic weight or mass number. Atomic weight or mass number. So this mass number is sum of nucleons. Sum of nucleons means what? Number of neutrons plus number of protons. Okay. So this is equal to number of neutrons plus number of protons. So I can write here atomic weight is equal to number of protons plus number of neutrons. I can write further atomic weight is equal to number of protons means what? Atomic number. Just see there I have written. This is atomic number. So atomic number plus number of neutrons. So this gives us an equation that you need to remember, that number of neutrons will be atomic weight minus atomic number. So copy this, then we will talk about quarks and leptons. Okay. Now let's talk about quark. We have 6 kind of quarks: up quark, down quark, top quark, bottom quark, strange quark, charm quark. But we have to study only 2 kinds of quarks as of now. we are going to study only up quark and down quark. Okay, other quarks we will not touch because UPSC has not yet touched quarks. But yes, you will find questions on quarks or terms like quarks in previous year questions or in any test series. So at least we should do these two quarks, right? And let's come to lepton. Leptons have made two things. One is your electron and other is your neutrino. What is neutrino? We will see after the break. Okay, the first we'll finish this. So your leptons have made two things. One is your electron and other is your neutrino. Okay, and quarks we are having of two types for our understanding. One is your up quark and other is your down quark. Okay, up quark is having plus 2 by 3 charge and downward quark is having minus 1 by 3 charge. So quarks have partial charges. Complete, okay, means charge in whole number is not there. It is partial, plus 2 by 3 and minus 1 by 3. So my question to you people, you have to answer this, then I will answer. Two questions are there. So first answer this. How many, of course minimum number of up and down quarks are required for a proton? Means protons are made up of quarks. So how many up quark and down quarks are required to make a proton? How many means minimum number of I am asking. Okay, I will give you hint. Hint is proton has plus 1 charge. So 1 minute is there to post your answer. Okay, we have got few response like Chava has given 2 up and 1 down quark, Anand Kumar 3 up 3 down, 2 up and 1 down, 2 up and 1 down by Rohit and Dhananjay. Yes. So Chava, Rohit, Dhananjay, you are right, 2 up and 1 down. Just see, if I take 2 up quark and 1 down quark. Okay. So 2 up quark will have plus 2 by 3, plus 2 by 3, just see the charge, we have to maintain the charge, and 1 down means minus 1 by 3. So the LCM will be 3, 2 plus 2 minus 1, 4 minus 1 by 3, 3 by 3 is equal to 1. So clearly proton has plus 1 charge, I have missed 1. So plus 1 charge and 2 up quark and 1 down quark is giving you the same. So up quark, just write it upward direction and down quark like this. So this is what is your proton. Same question is valid for neutron. For neutrons, how many up quark and down quark is required? Again you have hint, neutron has 0 charge. neutron has 0 charge, and your time starts now. बहुत दूर है यार, नहीं दिखता मुझे. ये लैपटॉप ऑन नहीं कर सकता. एक्सटेंशन कॉर्ड है ना. Yes, Chava has given her answer 1 up and 2 down. Very good. You are doing good. Yes. Just see this. So neutron is having 0 charge. So here we will need only 1 up and 2 down quarks. 1 up means what? Plus 2 by 3. 2 down means minus 1 by 3. Minus 1 by 3. Let's take LCM. 2 minus 1 minus 1. 2 minus 2 by 3, that is 0 by 3 is 0. So you got 0 charge. So neutron is made up of 1 up quark and 2 down quarks. So this is your neutron. How many up quarks and down quark are required for making electron? Suppose this question is asked. Okay, never answer that way, because electrons are made up of leptons. Are you getting this? Electrons are made up of lepton. So never answer ki this much up quark and this much down quark will be required. Okay, never try to manipulate the equation, because electrons are made up of lepton. Okay, do not try to make it from quark. Okay, just see the PPT. Let's have the quick revision of the things we have done. PPT. So lepton is giving you electron as well as neutrino. Neutrino we'll see after the break. And quark, suppose this is plus 2 by 3, 2 up quarks and 1 down quark, minus 1 by 3 charge. So this is what is your proton. This is what I taught you, right? So proton is 2 up quark and 1 down quark. So it will behave like this. Just see this, there will be a spin. So the red one is your up quark and green one is your down quark. So are you able to see that this spin is there? So they have this sort of spin in them. So this is your proton. And 1 up quark and 2 down quark, this is your neutron. So this is also having same. You can see that. So they will also spin in the same fashion, but I have shown this way. So 2 down quarks and up quarks. So they are just in motion all the time. So we'll take a quick break. Okay. After break we'll start from here. Isotope. Okay. So let us resume with isotope. So what are isotopes? Okay. First write the definition, then we will discuss. Right. Isotopes are elements having same number of protons, but different number of neutrons. In other words, these elements have same atomic number. These elements have same atomic number but different mass number. Same atomic number but different mass number. Have you written this? Okay, now let's understand what I'm trying to say. For example, hydrogen H11, H12 and H13 are known as isotopes of each other. Okay, these are isotopes of hydrogen or isotopes of each other. So what I have made you written, that different number of proton, same number of proton but different number of neutron. So if you remember that X, A and Z, so here there was mass number and here it was atomic number. And atomic number was equal to number of protons and this was proton plus neutron. Just look backward. So number of protons in each case, I can write this 1, 1 and 1, that is equal to the atomic number. And number of neutrons was mass number minus atomic number. The formula you see, we had derived the formula. So mass number is here 1, 1 minus 1, 0. Mass number 2, 2 minus 1, 1. Mass number 3, 3 minus 1, 2. Are you able to see number of protons in each case is same but number of neutrons is different. So that is why these are isotopes of each other. This difference sometimes may lead to radioactivity that we are going to see within 5 minutes. Okay, so that difference may lead to radioactivity. There is one more isotope that I want you to remember, but before that this is known as hydrogen. This is known as deuterium and this is known as tritium. So hydrogen forms your normal water. So whatever the normal water you intake or you use for your drinking or any other purpose, so this H2O is belong to this hydrogen category. Deuterium is known as D2O. In other words, it is known as heavy water used in nuclear reactors. We will see today. And there is one hard water that we will see tomorrow or next class. So what is that hard water? I will explain that time. So this is heavy water. That is why this isotope is very much important. There is one isotope of carbon also, C612. So number of protons, it will be 6 in 6 all cases, and neutron will be this minus this, yani 12 minus 6, 6, 13 minus 6, 7 and 14 minus 6, 8. Same atomic number, yani same number of protons and different number of neutrons. So that is why these are called isotopes of each other. Okay, understood? Now we will discuss nuclear physics in brief, okay, not in detail. That is not our concern. Nuclear physics, as the name suggests, copy it, okay, I am not going to dictate anything. So nuclear physics, as the name suggests, physics or study at the level of nucleus. So nucleus, you remember, where proton and neutron were there, right? So that is physics at the level of nucleus, or the study at the level of nucleus will be termed to be nuclear physics. It is categorized further into two parts. First is your nuclear fusion, and the other one is known as nuclear fission. Okay. Fusion means addition or merger. Okay. So in nuclear fusion, two nuclei or two nucleus merge together to form a bigger nuclei. So in nuclear fusion, two small nucleus fuse or merge to form a big nucleus. Example, this gives you helium, first deuterium etc. is formed, but we will not enter in that domain, plus stellar energy plus neutrino. So this is fusion reaction. This happens in stars. Okay, this reaction is found in stars. So where it is found? So this is example of the reaction, and it is found in stars. Nuclear fission. Fission is nothing but disintegration or breaking. Disintegration or breaking. So fission is when a big nucleus disintegrates into smaller nuclei. Example we are going to see nuclear fission in detail. Nuclear fusion is experimental at Earth or on Earth. We are trying to make nuclear fusion reactor. It will be taught to you in technology. Okay, ITER facility etc. is there for that. Even fission will be taught. I am just introducing because some concepts are there. They want me to cover here. So when a big nucleus disintegrates into a smaller nuclei, so that will be termed to be fission. Radioactivity. Okay, radioactivity is one of the manifestations of nuclear fission. Okay, one of the manifestations of nuclear fission. Radioactivity is of three types: alpha decay, beta decay, the last one is gamma decay. Okay, first copy this, then I will deal with alpha, beta and gamma decay and what is radioactivity. So just copy this first. First write the definition of radioactivity, then we will proceed alpha, beta and gamma decay. I will do it on board only. Right. Radioactivity. It is natural emission of radioactivity. It is natural emission of high energy radiations. It is natural emission of high energy radiations or nuclei from unstable elements or isotopes due to disintegration of their atomic nuclei. Disintegration of their atomic nuclei. Okay. So now just see the PPT just for a minute. Suppose if the intensity of white light is increased, okay, intensity of white light is increased, ever you feel rashes on your skin, you never feel rashes, etc. You never visit a doctor that intensity of white light was more, flash light was more, so I am feeling rashes. You never visit to a doctor for that. But if there will be high energetic particle, for example X-ray, gamma ray, okay, even alpha, beta, then you will feel some difficulty because these are high energy radiations. We have done in first class high energy radiations, but low energy radiations, for example your visible light, etc., will cause no harm. So radioactivity is naturally the integration of the nuclei, they break. Understanding this? So we will start with alpha decay. For once and all, I am asking you to remember these things. Alpha is a term used for helium nucleus in chemistry. Okay, this is used for helium nucleus. Beta is a term used for electrons, and gamma is a term used for gamma rays or high energy radiations. Okay, so radioactivity is what? In which disintegration of atomic nuclei happen, means something comes out of the parent nucleus. This is what is there, please read it. It is the emission of high energy radiations or nuclei from unstable nuclei or isotopes due to disintegration of their atomic nuclei. So a big nucleus will break and something will come out of the nucleus. So alpha decay, so here helium nucleus will come out of, very clear. So here what? Helium nucleus comes out or disintegrates, comes out of parent nucleus, right? Beta is a term used for what? Electron. So here electron comes out of parent nucleus. And gamma, as the name suggests, gamma rays. So gamma rays come out of parent nucleus. So when we can observe alpha, beta or gamma decay, okay, so alpha decay is often seen in bigger nuclei. like uranium. So bigger nuclei, they have more tendency to break. For example, a joint family. A joint family has more tendency to break because there will be 50 people in the house and the woman entering the kitchen is a marathon for them every day. So they will quarrel to their husband. But the entire blame game will be on the ladies. That ladies cannot handle within the house. That is why the home of the brothers have, separated. But the idea is, have you ever kept thing in mind that what happens to them in kitchen 3 times a day or 4 times a day? 250 chapatis, okay, these many sort of vegetables. So definitely they will quarrel and the home will start separating or disintegrating. So this happens in uranium nucleus also. It is very big, so it is unable to handle. Beta decay, it generally happens in, exceptions can be there, I am writing in general. It generally happens in isotopes like carbon 14. You remember carbon 14? And gamma decay. It happens two ways. First is, naturally it happens. So naturally in, suppose barium nucleus, they want to get stable. Or next, it also happens after alpha decay. So alpha decay is also precursor because after alpha decay, high energy is there with helium. So helium emits some gamma radiations to be stable. So these are some of the decays you can have. Okay. I was expecting a question from you. For example, alpha decay, you can clearly see, now see the PPT. You can clearly see that uranium is disintegrating into thorium and helium. There is no problem in this, right? But in beta decay, how electron is coming out? I am going to answer it. Electrons never reside in nucleus. Then how electrons came out of the nucleus? I have written this statement and nobody has countered it. Now gamma decay. Just see that barium nucleus, it releases some of the high energy radiations to be stable. So this is your gamma decay. Okay. Just see this, how alpha, beta and gamma are going to harm you. Okay. For example, alpha particles are least penetrative. Okay. They can be stopped by a paper or even by your shirt. Okay. So alpha particles are very less harmful to you because they won't be able to penetrate through any tissue, because whatever the dress etc. you are having, that will block them. Beta is slightly penetrative, but it cannot penetrate skin. So it may lead to some rashes etc. in skin, but skin tissues cannot be penetrated by the beta. Okay, for that they require some more energy, some acceleration. That can be provided by cyclotron or betatron. In last class we have done, na? So cyclotron and betatron, that can do the purpose. And the last one is your gamma. Gamma is highly penetrative. Okay, it can penetrate throughout your body. It can kill you. It has killed Iron Man also, right? Have you seen? So gamma is really a tough nut. We should avoid being exposed to gamma radiations. So the now question was there that I am going to answer you, and this is nuclear fusion that we have seen. Okay, and more discussion on this will be in second last class in cosmic physics, because it belongs to the realm of stars. So whenever I will be dealing with star, I will be telling you about this. Now in beta decay, how electron is coming out of parent nucleus. This was the question and nobody has asked. So see here, beta decay. Beta decay is of two types. First is your beta plus, other is your beta minus. Okay. It happens where number of proton is greater than number of neutron. So beta decay happens when in isotopes, when number of proton and number of neutrons are not same. That leads to radioactivity, right? So here number of proton is more than number of neutron, and here neutron is more than proton. Here neutron is more than proton. So since proton is more, so here proton has the responsibility to give you neutron plus electron plus neutrino. Okay, so proton disintegrates to give this, and in this beta minus, okay, in this beta minus, here neutron will do the purpose. Neutron will give you proton plus electron plus antineutrino. Actually, here electron is not formed, but positron is formed. Positron is antimatter of electron. This reaction was known to humans around around World War II. Okay, and this is electron. Here electron is formed. There is no issues. And this antineutrino is nothing but antimatter of neutrino. So what is this antimatter we are going to do in last class? Actually something has some relation. That is why I told you not to skip any class, because these reactions will have their purpose those days. Now just see this beta decay. Here I am getting positron. Actually mass balance in these equations are not possible, and there is no explanation for this also. But charge balance is there. For example, proton is +1 charge, neutron is 0 charge, and positron is also having +1 charge. Here neutron is having 0 charge, proton is having +1 charge, electron is having -1 charge. Suppose here we were getting electron only, so the charge balance was not there in the equation. So by that you can remember that it is known as beta plus, and we are getting positron. So positron is electron but having just opposite charge. So that is why it is called positron. Okay. So are you able to see, even if electron is coming out of the nucleus, it is because proton or neutron are transforming themselves into electron. Okay. So I hope that you should not have any doubt that from the orbit why this happened. Copy these reactions. Earlier I thought that these reactions are not important, but in 2018 I saw that in Rajasthan State Service, in mains they had asked about this beta decay. But yes, I was teaching this, so I don't know that whether these things can be asked, but they will have some applications. Okay, now we have seen neutrino everywhere, antineutrino here, okay, and in nuclear fusion also neutrino was there. Lepton was making neutrino, right? So what is this neutrino? Okay. whatever I'm going to tell you, just remember once for all. Neutrinos can tell us about the stars and galaxies, the evolution of universe, everything. For example, if you see, this reaction happens in sun. So every moment neutrinos are formed in millions, okay? So millions of neutrinos are formed and they are wandering in the universe. Do you believe that even before thousands of years, these neutrinos were getting formed? So these neutrinos have seen everything, so they have a lot of information. So you can consider them as intelligence agent. For example, I am considering raw agent or CCTV cameras or even mohalle ki chachi. Okay, the lady has all sort of information. So neutrino is your raw agent. So we will remember like this. What are the features of raw agent? First is, neutrino is massless. Okay. For example, raw agent is also very fit. Okay, that is massless. Next is not massless actually. Mass is near to zero, not massless. Only thing massless is light and nothing else is massless. So they are fit, so massless, no extra fat. Chargeless. They do not have any political affiliation, whether it is Congress government or whether it is BJP government or whether it is Aam Aadmi Party. Even Kejriwal can become PM one day. So I don't know. Anything can happen in politics. Okay. So they do not have any affiliation to any of the political parties. So that is why they are chargeless. Do not have any affiliation. If they are raw agent means what? Present everywhere. Okay. For example, at present, almost 3 lakh neutrinos are passing through your body per second, but you are unable to observe or unable to notice. Okay, so they are present everywhere. For example, your cook can be your raw agent. Okay, you must not be knowing. Even your father is working as a raw agent, but you are not knowing. You think that he is simple LIC agent. Okay, so they are present everywhere, right? So they are second most abundant particle in the universe after light. Extra information. Okay. If they are raw agent, do not you think they will have lots of information, right? They will have lots and lots of information if raw agent are there. And the most important characteristics, difficult to catch. If you will catch them easily, तो agent का आएगा, वो भी raw का. Okay, it's difficult to catch. Neutrinos are formed during both fission and fusion reaction. So do not take it lightly that it will be formed only in fusion. In fission also we have seen, right? Beta decay, etc. So you remember these things and read articles. Okay, now let's deal about half-life. So radioisotopes have some features. For example, let me show you the feature. Okay. Suppose these are chunks of radioactive material. Okay, these are chunk of radioactive material, and suppose their half-life is 10 years. Half-life is 10 years. So after 10 years, half of the original sample will be gone. Suppose this is 100 gram, this is 200 gram, and this is suppose 300 gram. So do not think that 50 gram of this is gone, so 100 gram of this will be gone. 50 gram of this will be gone. No. Half of the original sample will be gone. So here 100 gram will be lost, like this. And in this case, half of the sample will be gone. So radio isotopes decay at constant rate. So time taken for half of the original sample to decay will be considered as half-life. Okay. Just see one more time in other way. Suppose this is your radioactive sample and 10 years is the half-life. So after 10 years what will happen? Half of the sample will be gone. Yes, I hope this is understood. Next 10 years, rest half will be gone. Next 10 years, next half will be gone. Next 10 years, remaining half will be gone. Next 10 years, these half. Next 10 years, these half. So don't you think even after multiple half years, some traces will be left in the radioisotopes. Some traces will be left. So these are Oogways of Kung Fu Panda 1, who will never vanish until they go for Mahaparinirvana by themselves. Okay. So this is what is the property of them, that vanishing is not possible. Please write about this. Radioisotopes decay at constant rate. Radioisotopes decay at constant rate. Next you write the time required by the isotope to decay to its original by half is known as half-life. Is known as half-life. Okay. Now how age of the fossil etc. is extracted by this method we are going to see. So first look here, then I will discuss. Every organism has these carbons in them. I am not writing that way, C612, shortcut is there. C12, C13, C14. These are the isotopes of carbon. So every organism have these carbon. Around 99% of your ecosystem has this carbon. 1% is yours, C13, and this is found in traces. These two carbon are stable form of carbon. This carbon is unstable, or in other words, radioactive. Radioactive. Okay. So for a living organism, we consider two types of carbon, C12 and C14, because one is stable and one is unstable is okay. So this is a stable form of carbon and this is unstable form of carbon. So every organism will have C12 and C14 in them. For example, you are also having C14 in your body. I told you C14 will be decaying at constant rate. So every moment C14 is decaying and it is killing you. Radiations are coming out of your body and it is killing the nearby person also. So one brilliant idea, do not sit too close to any individual. Okay. So C14 is your unstable form of carbon, right? Now just think on these lines, what I am going to tell you. So it is decaying, but you are still alive. Why? Because whatever the nutrition you take, whatever the food you intake saves you. It compensates for the decay. Okay. So this nutrition by organism compensates for the decay. So it is the position when you are alive or the person is alive or organism is alive. So at this point C12 by C14 ratio in the body of the organism will equal to C12 by C14 ratio in the environment. Right? But when the organism is dead, C14 decay is not compensated. So because of that, C12 by C14 ratio in the organism will not be same to the C12 by C14 ratio in the environment. And this is how age of the fossil is found. The researchers exploit this equation to find the age of the fossil or the dead organism. Understanding this? So just write this. Every organism have two sets of carbon in them. Every organism has two sets of carbon in them. C12 stable, C12 stable and C14 unstable. And C14 unstable. Unstable. Right. C14 decays at constant rate. C14 decays at constant rate. Decays at constant rate. But the nutrition of the organism compensates for this decay. But the nutrition of the organism compensates for this decay. Because of this, C12 to C14 ratio, because of this C12 to C14 ratio in the organism, C12 to C14 ratio in the organism mirrors the environmental level, But when the organism is dead, this ratio is no longer same. This ratio is no longer same. This difference is exploited to know the age of the fossil. To know the age of the fossil. Okay. Now try this question. This question though should be covered in technology, but I have to deal some concept. So that is why in general, actually I am teaching for the view of general science. In technology, India's 3-stage nuclear program will be taught to you. So the faculty will deal with it. Okay. But still I am asking you to try this because I need to tell you some concept. So I have got some answers. Okay. Vikram Anand have given option C. Chava has gone with option A, Vivek has gone with option A, and Palash has gone with option C. Okay. Let me just introduce India's 3-stage nuclear program. Okay. Do not expect me, this is at least 1 hour or 1 hour 30 minutes topic. Rohit Kumar has also given option A. Okay. So India's 3-stage nuclear program. This will be taught, don't worry. First is your pressurized heavy water reactor. Second is your fast breeder reactor. And the third one is advanced heavy water reactor or thorium based reactor. Sandeep Kumar Yadav has also given option A. Okay. So here it is talking about India's 3-stage, this is talking about pressurized heavy water reactor. Why? Let me tell you. Initially when we are having, okay, so uranium is the fuel. So in India, reserves of uranium are there, but fissile uranium is not there. So uranium is fertile or fissile. So almost 99% or 99.3% of the uranium is fertile in nature, and only 0.7% is fissile in nature. Fissile uranium can be used in reactors. Okay, these can also be used, but less efficiency. So if these will be used, efficiency will be higher. So that is why fertile uranium is converted into fissile uranium by a method called centrifugation. Centrifugation. Take it from me, this is a very costly process. Very costly process. So when infant India, post independence was there, India had no money. Though Nehru wanted that India should become a superpower, so he was interested in these programs. So Bhabha said, Nehru, can you offer me this much amount of money? Nehru said, you know the conditions. So Bhabha said, okay, let's design it this way. So the architect of India's nuclear program designed this way, that he said that, okay, initially we will use fertile uranium, then we will move to fast breeder reactor, and then to the advanced heavy water reactor. So he said that we will use fertile uranium instead of fissile uranium, because this cost is not with us. So what is difference between fertile uranium? Like fertile uranium is like this. There are very less sweet spots here. Sweet spots means where neutron is going to hit and you will get energy. In fissile uranium, sweet spots are very close and so much. So because of that, the probability of neutron hitting the sweet spot is more here, and hence efficiency is higher, right? Hence efficiency is higher. So in a pressurized heavy water reactor, we are using what? We are using this fertile uranium because of cost constraints, and now since the model is that, so you can't change also. So neutron is going to hit every sweet spot. So tell me, there is one neutron which is coming at 500 km per second, and there is another neutron which is coming at 20 km per second. So which neutron has more probability to hit sweet spots? Definitely which is coming at slower pace. It will take time to hit those spots, as well as it will remain for longer period in this fertile material. For example, you are driving at 100 km per hour and you are driving at 10 km per hour. So if you are driving at 100 km per hour, you will miss some nearby things to view. But if you are moving at 10 km per hour, you will see the things very clearly. So that is why slow neutron will provide more efficiency. So that is why heavy water is used. So heavy water is used to slow down electrons. So those who have selected option A, like Chhava and Sandeep and Rohit, Vivek, you all are right. To slow down electron, right? So now why we are selecting heavy water? So I taught you these things not because I was interested. These things will be taught to you in your class. I taught you these things because I am interested that why heavy water is used, why not normal water was used. Okay, just to clarify your concept. Now see, if you remember, heavy water is this H12. Normal water is H11. Yes, you remember? So in normal water, number of neutrons is equal to 0. In heavy water, number of neutron is equal to 1. So this normal water, if used to slow down the neutron, this will rather swallow the neutron. This will rather eat the neutron. Because of that, instead of slowing down the reactor, it is going to stop the reaction. But it is having one neutron. So this is going to hit that neutron and it is going to make it slow. Okay, it is going to make it slow, right? So this is going to stop the reaction and this is going to slow down the reaction. So we want the reaction to be slowed down. That is why we are using it. Understanding this? So it is used for the purpose of slowing down. Second thing is, since it is water, so it will act as coolant, no issues. But the primary function is slowing down the reactor. The primary function is not cooling down. Since multiple options are not correct, so primary function should be selected, not the secondary function. And in pressurized heavy water reactor, okay, cooling is not that important. Cooling is more important in fast breeder reactor because that their reaction is very fast and speed of neutron is very fast. So coolant has more importance in that case. Here also coolant is there. This heavy water can be used, okay, but the primary function is this. Since only one option is correct, so you are bound to choose this one. You understood why this is? So these are like those boys who have never got a girlfriend. So they react abnormally when they see a girl, but those boys, those are very stable. So that is what is the case here also. So option A is the right answer. My submission would be this. Anand Kumar, heavy water is also used as coolant. Yes, Anand, that is what I told you. Okay, I have got some answer. Sandeep has given option A. Yes. Option A by Chhava, Vikram, Dhananjay, everyone. Yes. So there are three devices we use. One is your Geiger-Müller counter. Okay, scintillation counter. And the last one is semiconductor device. So these three devices are used. Can you see the timeline of the question paper? It was asked in 2008. Okay. I don't know why UPSC has asked in 2008. But let me tell you a few things. Okay, UPSC is highly unpredictable. Okay, I told you that we cannot predict. In 2014 or I guess 15, I do not remember, a question was asked in UPSC regarding a coast of Odisha, etc. And it was written on the back side of KitKat wrapper. So that year when you used to buy KitKat, so KitKat had that information behind it. Maybe one of the question paper setter had eaten that KitKat and he gave that question. In 2008, a very famous movie came, Get Smart, in Hollywood. Okay, Anne Hathaway, and in that the device Geiger-Müller counter was used. Okay, that was based upon radioactivity. The agent thing was there. I don't know whether they have given this question after watching that movie. So what point I wanted to make is be observant. If you find that any KitKat or any other company, though I do not eat KitKat, okay, but still you be observant. I do not know from where, because that question was really shocking, that they are asking from the wrapper of a chocolate, and this 2008, I find that that movie also came in 2008. So I don't know whether this was the case or not. So A is the right answer. Anand Kumar has gone with option D. Rohit has also gone with option D. Yes, Becquerel is the right answer. If somebody is thinking about Madame Curie became famous because she died of radioactivity. She had done a lot of efforts and she died. And Vikram has also given the right response. Option D is the right answer. So there are some chances that you may select Madame Curie instead. So please do not do that. Sandeep and Chava also have chosen D as the answer. So electrochemistry we have done. Yes, last class. So this is your corrosion and this is your galvanization. So are you able to see? Yesterday we had seen galvanization. So how zinc plating can make your iron equipments safe for longer, and this shiny thing also adds value. And this is what is corrosion. So corrosion is what? Now few concepts are there. I will go for 2-3 concepts. Okay. So corrosion is what? Corrosion is decay. Okay. Decay of a metal. So decay of a metal is known as corrosion. In other words, it is formation of oxide layer on the outer surface of the metal. Okay. In case of iron, it is known as rusting. Jung lagna, rusting. Okay. For corrosion to happen, we need both moisture as well as air. Moisture means water, air means oxygen I am talking about. Okay. So for corrosion to take place, these two things are required. And really this is decay, so unwanted thing. Okay. So this is unwanted. You would not like that this should happen. So that is why electroplating of metal is done. Electroplating to save metals. So this is your corrosion. This much at least you should know. Now allotropes. Please copy the definition of allotropes. I will make you understand with examples just after a minute after you copy it. So this is saying that some elements have two different forms because the atomic structure is different. है ना? Atoms are bound in different structure. For example, humans, they walk like this, right, on their two legs. But some of the humans will walk different conditions, right? Some will walk like this, okay, not because they are having some limping problem, because of their weight also. Some will walk like this, okay. So there is different ways because of different structures they have achieved. Some fit person, there will be some model style also, yes. Like, understand, suppose there is some material of this type and 6 units are given to each of you. So one person did one thing, he arranged everything in a straight line. Other person did one thing, 3 together this manner and 3 together this manner. So a different structure was there, and this can be used differently. One person did one thing, 2 like this, 1 like this and 2 like this. Another structure was formed. So are you able to see, if all these materials belong to one element, suppose carbon, so don't you think different structures are there? So these will be used for different purpose, or they will show different properties also, right? So these are called allotropes. So these 3 structures are allotropes of each other because they are made up of similar atom but structure is different. So since structure is different, property is also different. For example, let's take carbon. So we have allotropes of carbon like graphite, diamond and fullerene, right? If you see the property of graphite, carbon is a non-metal, okay, non-metal. For example, iron is a metal, so that will conduct electricity, that will be prone to heat, right, and strong. The metals have different property. Non-metals are bad conductor of heat, bad conductor of electricity, and they are weak also, not very strong, okay, they are weak also, not very strong. Now see, when the properties change, so this graphite, being the allotrope, is a good conductor of electricity. Diamond, hardest material in natural form, naturally found, or in, okay, this is the hardest material we are knowing. I told you carbon is weak. Fullerene, it is weak, but fullerene, this shows high tensile strength. Okay. In the same fashion, we have phosphorus. Right? Black phosphorus, red phosphorus, white phosphorus. Okay. Phosphorus is again your non-metal. Non-metal means similar property that I have pointed there. But if you see black phosphorus, they are also good conductor of electricity. Red phosphorus, used to make matchstick. So heat element is there. Are you understanding this or not? Heat element is there. The tip, the head of the matchstick is red phosphorus, white phosphorus to create smoke. This is also used in matchstick or crackers, etc. So just see this, that in allotropic form they show some different behavior or property. Okay, periodic table. We are not going to do much in periodic table. Periodic table is nothing but family of the element. Element, whatever you see around you, like iron, carbon, okay, nickel, oxygen, bromine, everything is element. So whatever you find on the periodic table is your element. Okay. So this is the family making exercise. Suppose you know lithium, you know sodium, you know potassium, you know rubidium. If you know beryllium, you know magnesium, you know calcium. For example, if I know your father, definitely your properties will match to your father. Not all the properties, but yes, if you belong to a good family, if your upbringing is right, you will show similar property as your family. Right? So this is what is periodic table, a family of the elements. Now this is important for us. If you see, most of the elements in periodic table, almost 75% of the elements are metals. Very few metalloid. Metalloid, semiconductor is made up of metalloid. For example, silicon, germanium, etc. that you are finding in green patch, and the yellowish are non-metals. So if question comes, means question will not come directly, there can be a statement that most of the elements around us are non-metals. You may mark it right, because whatever the things you find, for example your pen, laptop cover, everything is made up of non-metal. Okay, so metallic things around you have declined in number, but let me tell you, most of the elements you find are metallic in character. Okay, so this thing you have to remember. One more thing you need to remember is that there are some non-metals which also conduct electricity. You need to remember this. So non-metals conducting electricity. First is in allotropic form. Allotropic form, you know, remember, first is your graphite, allotrope of carbon, and second is your black phosphorus. In natural form, selenium and iodine. Okay, I have got one response. Bromine is not the right answer, Vikram. I guess selenium is the right answer. Selenium is also an antioxidant. Okay, I guess you know about antioxidant. That saves you the free radicals formed inside your body during the process of metabolism. Yes or no? That is why you take vitamins. For example, vitamin A, vitamin E, vitamin C and selenium to counter the antioxidant form. So selenium is also the metal which is very essential part of your body. If the selenium content in your body is less, high chances of getting cancer. Phosphorus can be right, Rohit, but if it was black phosphorus, it is only phosphorus. So if naturally it is happening, you should mark it natural, then go for allotropic. Since only one option is correct, selenium is the best. Now give the answer of this, then I will give you one concept over here. Okay, Chhava has gone with option D. Yes, option D is the right answer. Anand has also gone with option D. Okay, so now just Vikram has also gone with option D. So just let's compare chlorine. Give heading disinfectants. So these two gases are used for disinfectants. One is your chlorine, other is your ozone. So chlorine is odorless gas, colorless, pungent smell is not odorless. It is having pungent smell. So chlorine, let's talk about something about chlorine. That chlorine can be used at dark. It is used at dark. Efficiency declines in presence of sunlight. Efficiency declines in presence of sunlight. So that is why it is used at dark. There is a formation of hypochlorite ions that is destroyed by the sunlight. So that is why it is used in dark. So at hotels etc., you must be observing that they clean their swimming pool at night, not because the guests are sleeping. It is because the efficiency of the chlorine declines in presence of sunlight. Second is, there is an odor in chlorinated water. Like the pungent smell you can clearly observe when the municipal water is at your house. Atul and Monica, you are also right. And it turns skin complexion to dark. Though it is temporary, but it will happen. If you are using swimming pool water for long, there is high amount of chlorine in it. So within 4-5 days you will appear to be more dark if you are dark already. Okay, so that happens. Ozone can be used anytime. Means sunlight has there is no odor involved and no impact on skin complexion. So you must be thinking why they are not using ozone. First is, we are using chlorine for long, so awareness about ozone is not that much, and chlorine appears to be a cheaper alternative than ozone. So that is why they opt for this. So you can clearly see that complexion becomes dark. So there was a song we need to change कि गोरे रंग पे न इतना गुमान कर, गोरा रंग क्लोरीन में ढल जाएगा, right? Because chlorine is impacting your skin color. Okay, let's do it. Less burden will be next class. These set of elements are known as inert gases: helium, neon, argon, krypton, xenon, radon, etc. Okay, so we are interested in the uses of that. Okay, these inert gases do not interact with anything. Okay, they are very inert, they do not interact. So gases and their uses. First is your helium. It is lighter than air, so that is why filled in air balloons or tires of aeroplane. See, hydrogen is also lighter than air, but hydrogen is not used because it is flammable. Okay, helium is non-flammable, so that is why it is used. It is non-flammable. Hydrogen is flammable, so that can be the last flight. One more thing, nitrogen is also used in tires. Okay, nitrogen is also in tires, whether it is aeroplane or roadways, there is no issues. There is a question by Atul that ozone is a layer in Earth's surface or gas. It is a gas. So the gas is accumulated at that layer. That is why it is known as ozone layer. Okay. So that layer is made up of gas. Ozone is a gas. Not good for you. If it will be around you, it will act as eye irritant, etc. Ozone is secondary pollutant from vehicles also. It will be taught in environment, etc. Okay, Atul. Now next is your neon. Neon is used in advertisement board. For example, Dr. Batra's clinic, etc. You must be thinking at night they are glowing. After neon we have argon. Argon is used in fluorescent lamps. Fluorescent lamps where we have seen plasma. Don't worry, in next class fluorescence will be cleared. Krypton for lasers, for surgical lasers rather. And xenon, the last one is. In headlight of vehicles for better clarity. Lighthouse, operation theater, wherever the light is there, they provide very, flashlight is very strong. So this is where we stop today. So we are just interested to know about what are the applications of these gases. That is why I just did it. Nothing to understand that it is used in advertisement board. Okay. So in next class we will continue with this chemistry, and if time permits we will start cosmic physics. One request to you people, that if time permits, okay, revise that portion of geography, if geography is over, in which sir has taught you about stars, planet, asteroid, Higgs boson, etc. if he has taught you. Okay, so let's meet next class. It is probably on Monday. Thank you.